So now, after a complete background of exponential representation of signals, wherein its dealing is easier as regards to differentiation, integration and all kinds of mathematical operations, we now come to a system. What is a system? Now, we consider one very interesting experiment which I am very much sure that nobody would have done. You must be aware of a voltmeter, but now since everything is digital, the moving coil galvanometer, permanent magnet moving coil galvanometer, and then converting this galvanometer into a voltmeter by adding a large resistance in series, that thing I think almost is not there, but still fortunately I say exists at junior college level. So you are aware of. In junior college, you might have also seen, or even in high school, nowadays with a digital multimeter, very cheap, the moving coil galvanometers or voltmeters has become an antique piece and is costlier. Means reverse thing. When aluminium was invented, that time in the parties in palaces, since aluminium was costlier, only kings and his family members used to have aluminium spoon, and other dignitaries were given spoons of gold and silver. So that aluminium was costlier that time. Like that, and what is the situation today? Aluminium is cheap. Whereas when digital multimeters were there, those were costly, and that time moving coil galvanometers were cheaper. Now were cheaper. Now digital voltmeters have become too cheap that moving coil galvanometer is just like aluminium. Digital multimeters were aluminium, moving coil galvanometers were like gold. The cost remains same. The cost of digital multimeter is reduced substantially. So anyway, that is not the important point. So a moving coil galvanometer, you might have seen it, a center zero moving coil galvanometer. So it is at center it is zero. Its full scale deflection current, there is a concept of F, I think now that was something to be considered very important in physics. Its full scale deflection current, let us say full scale is 45 degrees. And just for simplicity, I am not much specific values, but just for simplicity I say that a full scale deflection current on either side is 5.4 microamperes. So what will happen is, if I connect a resistor of 1 mega ohm in series with that moving coil galvanometer, then 4.5 volts will, a voltage of 4.5 volts, a series resistance of 1 mega ohm will give rise to 4.5 microamperes of current. So that would be, this angle is 45 degrees. So 4.5 volts will correspond to 45 degrees of deflection. So 1 volt will give rise to 10 degrees. 1 volt will give rise to 10 degrees. Is it clear? So what is input to A volt, what is input to a moving coil voltmeter? Input to moving coil voltmeter is electric voltage. Input to moving coil voltmeter. Moving coil voltmeter consists of a good quality moving coil galvanometer. A good quality moving coil galvanometer means that galvanometer who is having less IFSD. So we converted it to voltmeter by adding a large series resistance. We converted it and calibrated it such that 1 volt corresponds to 10 degrees. So what is input? So moving coil galvanometer is a system. Moving coil galvanometer with added resistance of 1 mega ohm, a moving coil galvanometer with IFSD of 4.5 microamperes, added resistance of 1 mega ohm is a system where input is voltage, volts, and output is angle theta, and the ratio is angle theta is equal to theta out. That is why I am giving subscript O, because it is output. Theta O, it will change as things change. Theta OT is equal to some constant K into V in T, and so what for a voltmeter, for a moving coil voltmeter, what is moving coil voltmeter, which consists of a moving coil galvanometer and large series resistance with appropriate calibration, is a system. For this system, input is voltage, input changes with time, output is deflection of the pointer, and it is angle theta. Zero position is 0, it deflects. So input V in T, output theta OT, and the appropriate calibration constant K. In this case, it is 10 V in T. 10 V in T. So this is the description of system. What is system? A system is having an input V in T and output theta OT. This is a system which is a PMMC with some resistance and resistance RS. A PMMC and RS is a system, a voltmeter. Now my question is a very simple question. After you listen the question, you put a pause, try to find out the answer. If you are able to find out, verify the answer by resuming the video. If you are not able to find out, then listen to the answer by resuming the video. My question is whether this equation is correct description of the system or not. The question is very simple. The question is very simple. Whether theta OT is equal to 10 into V in T is correct description of the moving coil voltmeter or not is the question. You can pause, think, and then you can resume. Now, instead of answering it directly, I will create a situation which will give answer on its own. Suppose if what I do, I take 4.5 volts deliberately I have chosen the values for simplicity, no specific thing. So I create a plus 4.5 volt and a minus 2 batteries, 3 cells I can take, or I can take power supplies, and then I make this ground. this terminal ground, this terminal is connected to voltmeter ground, and I have this terminal. So this is given as voltage VT per voltmeter. So what is voltage? Is plus 4.5 volts. This is 4.5 volt battery. So its center point is ground. So if this is also at the center, 0. If this is here, you have connected plus 4.5 volts. If you move to point A, you give 4.5 plus 4.5 as input. If you move to point B, you give minus 4.5 volts as the input. Now, what will happen if that is rheostat, which you can change either in a old big rheostat, or you can have potentiometer also. Very old big rheostat were costlier. Now that rotary potentiometers are there, those are cheaper. So you can use that. Now if you change the voltage, what will happen? If you change the voltage, it should change. Now if you decide to move the rheostat, you move slowly, reach A, this will move, reach, this is A, A position on rheostat, this I will say A dash, equal position on voltmeter, this I will say B dash. So this O, this I can say position O, origin. So you are at O, you start, you move slowly to A, this will move slowly to A dash. You move slowly to this, I can say O dash. You move to B, this will move slowly to B dash. So O is mapped as O dash, A is mapped as A dash, B is mapped as B dash, and when you do it slowly, you will see that it will trace. Now use some common sense. You move the speed of movement. And what will happen? Now again you can think, you can pause the video, come up with the answer and verify the answer by resuming the video. So what will happen? By common sense, you are moving it rapidly, very rapidly, which you are moving right now on this. This you can increase speed very large somehow, or you can, instead of here I am giving it manually, or you can give it through a signal generator also, which generates plus minus 5 volts or plus minus 4.5 volts, rapid waveform. So what will happen? You will find that if the speed, now this is after all a circular spring is there, that coil and all that arrangement is having some kind of inertia, Because of some kind of inertia of the physical system, this inertia will limit the maximum speed with which the pointer of the moving coil galvanometer can rotate, can deflect, can shift its position. So there will be some, theta is the angle, so there will be a maximum limit on d theta by dt max, and that will be depending on a good quality voltmeter will have this as larger parameter, a poor quality voltmeter will have this as smaller parameter. So d theta by dt max is the maximum rate at which this can move. Means obviously this is there everywhere and there is nothing wrong. So if I go on teaching at a rapid rate, teaching, or I record and then I think that there are many things which I need to tell, and so I can't cover it in time. So people criticize, sir, no, you are taking too much time, how can we spare this much time? So this is not correct. There may be criticism from students. Many others may also criticize. Then what I do, I record it, I upload it on YouTube, but before uploading, there is a method, there is a technique that I can upload the video at 1.5x. So 60-minute recording is compressed to 40 minutes, so it plays rapidly. Then you will say, no, why 1.5, 2x, 3x? Suppose if, I think, I don't know whether you do such practice while listening to the YouTube. So if I record it, while uploading, if I say that my 60-minute talk should be played in 20 minutes, what will happen? There would be a speed with which you can comprehend, you can listen. If I am moving beyond that, then there will be the connect between talk, listening, actual words and its interpretation would be lost. So, if the input is changing at a rapid rate and it is demanding the voltmeter to respond at a speed, its angle means if it is expecting that the voltmeter should deflect at its angular deflection should be at a larger speed than its maximum speed, it cannot deflect. It cannot deflect. So, what will happen? Naturally, if you are moving, so what will happen? If you are moving from this to this continuously, and if as long as you are moving slowly, it will be like this. So if you move fast, come back. So before you reach here, you have reached here. You are coming back. So naturally, by common sense, you can pause, think and resume. Naturally, by common sense, you will find that if you are moving from A to B and if you increase speed, then the point O will map to O dash, but this will shrink. So, and if you move at a very rapid rate, the voltmeter will, even though you are moving from plus 4.5 volts to minus 4.5 volts, the voltmeter, which is expected to deflect between plus 45 to minus 45, it will shrink to somewhere like plus minus 15, then further shrink to plus minus 5, further will shrink to plus minus 1 and so on. So naturally, if this equation is to hold good, theta OT is equal to 10 into V in T, then always this should be there. For every voltage at any given point of time, the theta should be proportionate. So you can change voltage using potentiometer, or you can have a sinusoidal generator. You can give some frequency in kilohertz, megahertz, and that you will find that if the frequency is too high, it is just like for a center zero DC voltmeter, if you do AC input, you will find that it shows steady at zero, but just vibrating to small extent. So what is conclusion is, this system description is wrong. Means such system cannot be created. Why? Because of physical limitation of the coil which is deflecting, spring and all that element. So since there is a limit on maximum speed, it is not possible, or in general it is not possible to create any system, it is not possible to create any system where input and output are directly related by a constant. Here output is angle, input is voltage. If you take amplifier, output is voltage, input is voltage. So in general, it is not possible to create that. So what I say, theta OT is equal to 10 into V in T. This cannot be created. So the question is, can this be? The answer is no. So this you can't create. And if you this can't create, then voltmeter you have, voltmeter is there. So theta OT is equal to what then? If theta OT is not this, then what? So one thing is very clear in any system is output of the system cannot change. Output of the system cannot change instantaneously so as to follow the input changes. Now, I said theta O, output theta cannot change to follow instantaneous changes in Vi. So theta OT can't be equal to something into V in T. If this is not, then what? Put a pause, think and come up with the answer. So the problem is inertia, lethargy, delay. All these things represent, all these words which I have used are applicable to whom? Are applicable to a student of an engineering college. Lethargy, inertia and delay. Okay, anyway, I'll leave that one aside. So because of this inertia, what is inertia? Sluggishness, lethargy, lack of promptness, then sluggish, all these things are delay. So if this is not, then can it be 10 into V in T minus delta T? Is it possible? Output cannot instantaneously reflect changes. Is it possible? This is the question. Now again, for getting answer to this question, you should also think. I will be explaining immediately. Those who want to have a self-try should put a pause, think, verify their answer or listen my answer. So prima facie we feel that this would be possible, but the answer is no. In that case, if this is possible, then it expects impossible expectation from the system. The voltmeter should produce the output which is proportional to input at some time ago. It requires infinite memory. And also, why this was not possible? Because output cannot catch the speed. So just by delaying, you can't increase the speed. So there is a limitation of speed of movement, and also means sluggishness is not immediately, means the system is sluggish, there is inertia for the system, there is lethargy for the system. By introducing a delay, you can't give solution to all. So this is impossible, which immediately we find. This is also impossible. Just think what kind of capacities this voltmeter should have. Voltmeter should remember the input. If this delta T is 1 millisecond, deflection now should be proportional to input 1 millisecond back. deflection at next instant should be proportional to next input. At that next instant 1 millisecond back, it's impossible. So it is not possible to have the output which is proportional to input at that point. Also it is not possible to have output which is proportional to single input at some previous point. Then what? If neither this nor this, then theta t is equal to, so theta ot is output, v in t is input. So theta ot is what? Is 10 is a multiplier, 10 into what? You can put pause, think and verify the answer after resuming. Now, listen very carefully, it's a very interesting question. What happens is, a system is some kind of arrangement of some physical entities. So, just like we teach you, it creates some changes within you and you attain something, and this is a continuous process. Similarly, voltmeter applied to the moving coil which is put in the magnet, that creates some changes, and sluggishness means inability to instantly respond, but rather it remembers some kind of remembrance is there automatically in the system. Some kind of differential relationship, some kind of retention ability like that. So in all, what it does is, it is law of averages. So output of any system is proportional to the average input over some past period. How much past? So it is theta ot is equal to 10 into average of v in t over last 1 microsecond. Theta ot is 10 into average of v in t over last 1 microsecond. How exactly it is 1 microsecond, I remember, and how exactly plain average. In fact, it is not so. It is not a plain average. Rather, it is, so what you are today is because what you received now, prior to this instant, prior to this last so many years. So it is not that, means whatever you have listened in second year you remember everything, and whatever you have listened first you forget it, it doesn't happen. So your today's state is because of all things were accumulated things which you received till now. So instead of it is plain average, what? So this is a very, and this is applicable not to voltmeter, to any physical system in the world. This is not applicable to voltmeter, this is applicable to any physical system in the world. That is, let us say theta ot as a representative. Theta ot is equal to some constant, I did 10 here, into weighted average of V in of all past V in T. All past V in T. All past till the beginning. One thing is that weights are high near and weights are low as you move ahead, as you move beyond. So current, in determining current output, inputs received in recent period are weighed more and inputs received in previous period, earlier period, are weighed less. So output is some constant into weighted average of past VT, or in general this can be a multiplying, then average there is no point. So what we can say? We can say it as weighted sum. 10 and then average is same concept. Weighted sum of all past V in T. However, how to sum it? Previous V in T, these are not separate samples, these are continuously available. And therefore, what we say, theta OT is, instead of weighted sum, as it is continuous input, we say weighted integration of all past VTs. And then HT tells us the weight. So how exactly this weighted integration? This is called as, so current output is weighted integration of all past inputs. So V in T is to be multiplied by V in T which is received earlier is to be multiplied by different weights. That weights are defined as HT, that is the system transfer function. We will be elaborating it in detail in the next lecture, but prior to that I introduce a new concept of HT, where HT represents the weights with which the inputs received T time ago is responsible in determining the current output. HT represents the weight with which the input received T time ago is contributing in determining the current output. So HT and V in T, HT is weight function, V in T is input signal. So HT and V in T are appropriately multiplied effectively. This is called as convolution. So we will be coming to the convolution integration in the next lecture. If you think that it is possible for you to read convolution earlier, it has been covered in mathematics, but for our interpretation it would be more appropriate if you come up with some prior reading. I think this is something which is quite fundamental for any kind of system in the world. No system in the world can respond to input instantaneously. So an instantaneously responding system where theta OT representative is equal to some constant into V in T is impossible. Theta OT will be weighted integration of all previous V in T. This is called as convolution integration. We will elaborate detail in the next lecture. I think it is appropriate now to stop here. Thank you.